Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In this video, I am going to explain about introduction to blackbody radiation. So we know that blackbody radiation is nothing but the black body refers to a electromagnetic radiation emitted by an ideal body that absorbs all the incident radiation and it will emit all the radiation incident on it. Okay, so irrespective of wavelength or the direction, a black body does not reflect the light. Reflect or transmit the radiation. It only absorbs and emit energy. The radiation emitted depends only on the temperature of the body. It's not on its material. The classical physics failed to explain this phenomenon, so leading to the birth of the quantum theory through the Planck's theory of radiation. Okay, so the black body is nothing but, so this is the black pigment. Any material is coated with a black pigment, so nearly a black body. It absorbs all the radiation and it will emit all the radiation, all kind of radiations, all kind of wavelength, right? Okay, so it will not reflect or transmit the light or any kind of waves radiation into it. Okay, so this is called a black body. So the characteristics of black body radiation, so the continuous spectrum, the temperature, so continuous spectrum. So the emitted radiation covers a continuous range of wavelength, so not just a discrete line, so it has continuous lines, like it emit all kind of radiations, right? Okay, so it's temperature dependent. So both the intensity and the peak wavelength of the emitted radiation are directly determined by the body's absolute temperature. So it's only depending on temperature. At particular temperature, so we maintain at the particular temperature bath, so it will emit that kind of wavelength. Okay, so while increasing temperature, the energy of the radiations also will increases. Okay, so so these materials are independent of material. The radiations characteristics are universal and it do not depending on the specific material, the composition or the surface properties of the object. Okay, so the Rayleigh-Jeans law. So the classical prediction. So in classical theory it was failed to explain this phenomenon. So that's why we move on to the quantum theory. So we know that classical theory is nothing but the macroscopic theory. So quantum theory is the microscopic theory. So, have you wondered why hot objects glow red or white? So, why does iron change color when heated? So, these questions lead us to an important concept in modern physics called blackbody radiation. So that this topic played a key role in the birth of quantum mechanics. So in this video, we will clearly understand what is a blackbody is, what blackbody radiation means, and so why classical physics failed to explain it. So the black body, we know that it will nothing but it absorbs all the radiation and it will emit all the radiations. Okay, so practical realization. In practice, a black body is realized using a small hole in a hollow cavity. The radiation entering into the hole undergoes multiple reflections. So during multiple reflections, it will absorb all the radiations. So when the cavity is heated, the radiation emitted through the holes behaves like a black body radiations. So why? So what is black body radiation? So the radiation emitted by a black body in a thermal equilibrium is called black body radiation. As the temperature increases, the intensity of the radiations also increases. The peak wavelength shifts to the shorter wavelengths. So this behavior is called Wein's displacement law. So failure of classical physics. So classical theory like Rayleigh-Jeans law failed at short wavelengths and predicted infinite energy. So known as ultraviolet catastrophe. So this contradiction showed that the physical concept physics was incomplete. Okay, so the importance in the Planck's explanation to solve this problem, Maxwell Planck introduced the idea that energy is emitted in the discrete packets called quanta. So this leads to the Planck's radiations law and marked the beginning of the quantum theory. So these two called Boltzmann's law. So the real life examples of blackbody radiations are color on the heated iron, so the filament on the incandescent bulb, and the sun behaving approximately as a blackbody. So sun is the source of blackbody. So the blackbody radiations explains how object emit energy based on its temperature, and its lead to the quantum mechanics revolutionizing the modern physics and technology. So this is nothing but so the quantum theory explains the blackbody radiations. So blackbody is nothing but it absorbs all the radiations and it will emit all the radiations. So while heating, blackbody radiations is entering into the black pigment hollow sphere. It will absorb all the radiations. So while absorbing the radiation, so atoms in the cavity walls will starts vibrating. It will produce the starts vibrating. So it heated the atoms. Okay. After that, in the particular temperature box, it will emit all kind of the radiations. Okay, so it absorb all the radiations and will it emit all the radiations. So particular temperature, it will emit particular wavelength of radiations. Okay, so this is called blackbody radiations. Thank you all.